Hello students, in this video we'll discuss a problem on regular Falsy iterative formula. So here we have to find the root of the equation x e raised to x is equal to cos of x. To find the root of the equation, first we should write it as f of x is equal to 0. So that is, here take cos on the left hand side. So it is x e raised to x minus cos of x is equal to 0. So that means that the function f of x is x e raised to x minus cos of x. To find the root of this equation, first thing we need to remember is that always your calculator for the calculation, it should be in the radian mode. So remember, trigonometric functions should be evaluated by taking in a radian mode. So they have already given that the root is lying between 0 and 1. So if the root lies between 0 and 1, it satisfies the intermediate value theorem. The intermediate value theorem says that if any root lies between a and b, then f of a into f of b is always less than 0. The product of a, f of a and f of b is negative. So here they have given the root is between 0 to 1, 0 and 1. So we'll verify whether the root is between 0 to 1 or no. So put x equal to 0. So it is e raised to 0 minus cos of 0 is equal to minus 1. So take f of 1. So 1 e raised to 1 minus cos of 1 is 2.1779. So we can see that this is negative and here it is positive. So therefore f of 0 and f of 1, the product of these two is a negative number. This implies that root lies in the interval 0, 1. Now the regular Falsy iterative formula is given by x is equal to a f of b minus b f of a divided by f of b minus f of a. Now here we can continue with by taking 0 as a and 1 as b. So we can see that minus 1 and 2 are very far away from 0. When any point is the exact root, the value of that function will be equal to 0. So to reduce the number of iterations, so here what I am going to do it is, I'll take a midpoint of these two. So it is a midpoint of x is equal to 0 plus 1 divided by 2 will be a 0.5. So find f of 0.5. So f of 0.5 is 0.5 e raised to 0.5 minus cos of 0.5. So that is equal to, so if you calculate in the radian mode, it is 0.0532. So that again compare f of 0 and f of 0.5. So they are both of them are negative. So that means that the root lies between 0.5 to 1. Okay, so we can continue with by taking a equal to 0.5 and b equal to 1. Still closer roots if you want, just check it any point near to that 0.5. So if I go for 0.6, so we can see that it is 0.6 e raised to 0.6 minus cos of 0.6 is equal to 0.2679. So here the product of these two, we can see that one of them is less than 0, another one is greater than 0. So the answer is lying between 0.5 to 0.6. So by doing this, by taking the smaller interval, we can reduce the number of iterations here. Otherwise, as it is with the 0 to 1, taking a as 0 and b as 1, we can solve the problem. So the bigger interval is reduced to the smaller interval by taking nearer the values. Otherwise, you can just compare 0 and 1. So you see that the minus 1 is closer to 0 the value of the function at 0 is closer to 0. So therefore put the values near to that 0 and find out the smaller interval of that. Now, so take the first approximation. So first approximation or the first iteration is, so take A is equal to 0.5 and B is equal to 0.6. So f of A is equal to value of the function at 0.5 is 0.0532 and f of B is f of 0.6, which is 0.2679. Substitute in the regular falsy iterative formula. So here the first iteration value is taken as x1. So A is 0.5, f of B it is 0.2679 minus B 0.6 minus of 0.0532 divided by 0.2679 minus 0.0532. On simplifying this, we see that x1 is equal to 0.5165. Now, so when we started with the interval 0.5 and 0.6 and we got the answer 0.5165. So to take the next iteration, is there either it is possible that the root is lying between 0.5 to 0.516 or the root lies between 0.51 to 0.65. So for that find f of 0.5165. So that will be equal to 0.5165 into e raised to 0.5165 minus cos of 0.5165. On simplification, we get this as minus of 0.0038. Now compare f of 0.5165 and f of 0.5. F of 0 is minus of, this is also minus. So that means that the root does not lie between 0.5 to 0.5165. Here if you see 0.5165 is negative, 0.6 is positive. So therefore the root is lying between f of 0.5165 and 0.6. So f of 0.5165 and f of 6 are having opposite sign. So the next iteration will carry out with by taking a equal to 0.5165 and b is equal to 0.6. So take the second iteration. So here a is 0.5165 and b is 0.6. So f of a, it is the value at 0.5165 is minus of 0.0038 and f of 0.6 is equal to, or f of b is equal to, it is 0.2679. Substituting these values for the x, so x2 for the second iteration, it is 0.5165 into f of b, which is 0.2679. So multiplication of these two minus 0.6 into 0.0038 divided by 0.2679 minus of 0.0038. Simplify this. So x2 is equal to 0.5177. It is 0.5177. So this is the second iteration value for x. Now whether to carry out the next iteration or not, just compare with x1 and x2. x1 is 0.5165 and here x1 is 0.5165 and here it is 0.517. If the question asked is up to 3 decimal places, so you can see the up to 3 decimal places, the answer is almost the same. you can stop it. So here I am solving the problem for up to 4 decimal places. So therefore, as the fourth place is different here, I'll go for one more iteration. So therefore, we go for calculating f of 0.5177. So it will be 0.5177 e raised to 0.5177 minus cos of 0.5177. So this answer will get it as minus 0.0004. Now compare whether f of 0.5165 and f of 0.5177, this value and this value are of opposite sign, or whether the f of 0.6 and f of 0.5177 are of opposite sign. So here we can see that f of 0.5177 and f of 6 are of opposite sign. So the root is lying between these 2 points. So go for the third iteration. Go for the third iteration. So here take A is equal to 0.5177 and B is equal to 0.6. So f of A is minus 0.0004 and f of B is equal to 0.2679. Substituting in the iterative formula, it is 0.5177 into 0.2679 minus 0.6 into minus 0.0004. This is divided by 0.2679 minus 0.0004. On simplifying, we get x3 as 0.5177. Now compare the value of x3 with the x2. So here, as we are solving up to 4 decimal places, x2 and x3 are same. So therefore, we conclude that the solution of this problem is equal to x3 and it is equal to 0.5177. The solution of this problem is equal to 0.5177. Thank you for watching.